There, folks.
Which one? What area? No, area. Area.
So we'll start with questions, right? Last time we had finished 1-7, correct? Okay. So at this point, you should be able to do all the way through 56. If you guys have any homework questions, I'd be happy to, knock some of those out for us. Yeah, questions. 48, sure. You know what? I'm going to do it this way. There's a lot of directions here. I'm just going to screen cap this whole section of stuff. All right. So first things first, it asks if the relation is a function or not. Probably easiest way to do this, type into my calculator and take a peep. So I'll do that real quick. Alpha y equals gets me, and then the first option gets me that vertical fraction bar, which I prefer because it makes it much easier to type it into my calculator correctly. And then I graph stuff all the time in all my classes, so I always just pick Zoom Standard. Looks like that's going to pass a vertical line test to me, so certainly that's a function. Part B asks for the domain and range. For one of these, I probably am going to do this just using the calculator or looking at the picture rather than trying to do this algebraically, especially with the range part. That can be kind of tough. I notice that there's probably a piece of this graph below that I can't really see very well. So I'm just going to change my y minimum here a little bit so I can see further down on the graph. So I just change that a little bit. So if I look here, it appears that I have maybe a vertical asymptote here at -4. Agree with that? And I see a horizontal asymptote here. It looks like -9. You guys see that? So any other x value, all the way from -infinity to -4, and then every x value after -4 all the way to +infinity appears to have a point that corresponds to it. Does that, you guys see that from the picture? So for the domain, I'm just going to write like a two-part interval going from -infinity to -4, and then -4 to +infinity. Notice that -4, both sides, I'm going to use a parenthesis because there is no point that has that x coordinate -4, because that's where that vertical asymptote looks like it is. I'll do the same thing now for the y coordinates. If I look, I can go down as far as I want, and I have a y coordinate until I get to like -9, and then there's no y coordinate there. And then after -9, any y coordinate I pick, there's a point with that y. So looking very similarly to the domain, I'll write -infinity to -9, and then -9 to +infinity. Part C asks to determine if the relation is 1-to-1. Well, my 1-to-1 check is a horizontal line test, right? And there's no horizontal line that intersects this more than once. So I'll say, yes, this is 1-to-1 because we passed the horizontal line test. And then it says predict if the inverse relation is a function or not. Well, I would say yes, since f is 1 to 1, f inverse is a function. And then part E asks us to find this algebraically, and that's probably likely the place where the real question is. So, since this is already written as y equals, I don't have to worry about kind of the first step of finding our inverse process. What I really need to worry about here is just getting the x by itself. And that'll be a little bit tricky. I'm going to start, though, just by multiplying both sides by 9. I'm sorry, yes, adding. Did I say multiplying? That's a big oopsie. Yeah, thanks for being on top of that. I meant adding. You ever write something and then say something different? Happened to me. Okay. At this step, I want to get the x out of the denominator, because I know I can't get that x by itself if it's still in the bottom of the fraction. So I'm going to multiply both sides by x plus 4. Because on the right-hand side, that cancels the x out. And on the left-hand side, I get to multiply that stuff together. You could FOIL this out right now. I would recommend against it. It would be tempting to want to do that, but I would not. Because if the goal is to get the x by itself, I can just divide both sides by the y plus 9. And that already gets that stuff out of there. If I FOIL that out, then I have x's in more than one place, and it starts getting like, what the heck do I do with this? And if I make that realization to not FOIL, now things start to look really nice, right? Should be clear what to do next. I'll just subtract 4. Notice that those 4 and 3 over y plus 9 do not have a common denominator. So I can't combine the 3 and the 4 directly, so I'm just going to write it next to it. Could I make a common denominator here if I wanted to? Sure. I don't want to, though, because it's just like extra work for the sake of doing extra work. It's not necessary, so I'm just going to not. And my last step then is to swap the x's and y's. And because we didn't start with a function notation when I write my final answer, I'm not going to write that in function notation. I'm just going to leave it as y equals yada, 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 and call her quits. Joey, did that feel okay? Again, the trickiest step is probably this one right here, and thinking to divide the y plus 9 rather than FOILing those two things out, which would be quite tempting because it looks like a FOIL problem right there. But you do that, and then you have x's in more than one place, and it becomes a little bit more of a hassle. I think it's easier just to get rid of it as is, since there's no x in the y plus 9 part. Just get it out of there. Alondra. You should, yes. Yeah. Since the x, you'd have to then like take the stuff without the x's over, refactor the stuff with the x's, and you'd end up with the y plus 9 coming out again. But yeah, you could get away with doing it that way, and it wouldn't, still feasible to get to the right answer. Not wrong to do that. I think a little messier, but sometimes messier and obvious is the way to go than neat and sneaky, right? Because if you don't see the sneaky, I'm just going to go with messy and obvious. Others. Okay, sounds good. So at this point, we had finished 1-7. We're not going to do 1/8 right now. We'll do 1/8 a little bit later when it kind of fits naturally into building up to something in trigonometry. I want to hold on that one because we need those ideas later, but it's a little bit later. It's like a whole chapter or so later, and I don't want to like do that now, let it fade, and then come back and try to like, hey, remember when we did this? I'd rather just do it right before it. So I'm going to sit on that for a while. So this is going to be 1/7 ended, the chapter 1 portion that we're going to do for the chapter 1 test. So let's talk about what that's going to look like. So your chapter 1 test is going to cover your sections 1/1 through 1/7. The skills you should be able to demonstrate are determine if if a relation is a function. I'll have 4 questions that are asking you to do that. And you should be able to do that whether I give you a mapping diagram as your relation or a set of ordered pairs or a graph or an equation. Should be able to handle that. You should be able to find the domain of a function algebraically and provide that answer in interval notation. I'll have 2 questions like that. Remember, the trick there is that the stuff under square roots, you set greater than or equal to, greater than or equal to 0. And the stuff in the denominator, you can set just not equal to 0. Right? That's the trick for those. You should be able to write the intervals of increasing and decreasing given a graph. So if I give you a picture with some points labeled on it, you should be able to write the intervals of increasing and decreasing. You should be able to use your calculator to find the extrema, I spelled that wrong, and then classify them as like local or global, max or min. So remember using your calculator to do that min and max command. Should be able to do that still. And there's one question like that. It says it just way over there, and I want the words to be big enough so that you have a chance of reading them if you're in the back row. You should be able to prove if a function is odd, even, or neither. There'll be one question like that. You should be able to find all the horizontal and vertical asymptotes for a function and then justify your answers with a table. I'll have just one question like that. And then you should be able to perform function operations, so addition, subtraction, multiplication, division, or composition of 2 functions. I'll have 2 questions like that. And then you should be able to find the inverse of a function. And again, regardless of whether I give you that function as a mapping diagram or a set of ordered pairs or a graph or an equation, you should be able to write the inverse in the same form that I give it to you in. Is that okay? And then the last question here is, given 2 functions, you should be able to show that they're inverses using composition. Maybe I'll be specific there. Does that feel okay as to like what to expect? Again, this is the stuff we did in the homework, the stuff we talked about in class. It shouldn't be any big surprise here. It's like, okay, I remember talking about all of these things. Unless we like space cadet it out for a day or something, that happens. So to help you, I have a review packet I made. So like, again, like function or not, like domains, identifying discontinuities, intervals, increasing, decreasing, constant. Hi, thank you. Hi, thank you. Alondra and Peyton. We got a pass and a pass. It's like the Lions offense. Passes all over the place. No, I'm trying to making jokes. So again, this is due. This is part of a problem set. This will be not for Sunday, but next Sunday. This problem set will be the review. I have the review key attached here also, so that really no excuse not to try to do this and turn it in, right? Like it's gonna pop. There it goes. So like, with reasonable work shown in and everything. So it should be quite helpful if you're preparing. And then for this class, for every test, you're allowed a half sheet of notes. You can write on both the front and back of your half sheet. You can put anything you want on there. You can put example problems. You can put instructions. You can put whatever you need, like calculator help. Like whatever you want to put on there, it's yours. Write whatever you want on there. It has to be handwritten. Can't type it. And then try to use like 0.1 font and bring in your magnifying glass so you can have like the entire review sheet on there or something. Nope, it's got to be handwritten. And you have to turn it in, and you have to turn it in to me before any of the sections take the test. So the first trig and pre-calc test that's happening is third hour on Monday. So I have to have it in my hand before anybody in third hour has a test, so that they can't look at the test and be like, hey, you make sure you have this on there. Everybody has to turn it in advance. Ideally, you do that today. If you don't feel like you can do that today, that's fine. You can send me an email over the weekend, and I'll print out whatever you attach as your email and hand it to you on the test day. You can bring it in Monday morning, Monday during CT, like today during CT, anything, it's fine. I want you to do it, but I'm not going to take it after third hour people have a test in their hand, okay? The other time you might not get it is if you are absent on the test day. So if you're not on the day of the test, you don't get a half sheet. Even if you've prepared one and then you're absent, your makeup, you don't get to use the half sheet. Again, for the same reason, right? Does everybody feel okay with what to expect? The rest of our time today, you can spend preparing your half sheet, or working on your review, or asking individual questions if you have stuff that comes up. That's it. Feel good? Okie dokes.